Hello, I'm Anna from CS department. I've come here to demonstrate on the data structure program of the linear search and the binary search. The main aim of this program is to search a variable according to the given conditions, that the conditions come under the basis of linear and the binary. I've started the program with a header file, and then I've used a namespace standard, and then I've declared all the variables in the int. That is, I've used a variable of opt n, and I've used a variable array of 20, and I've used I, key and flag are just the variables there, and I've given a variable called choice, that is I've used a character for that, and then I've used a cout, that is enter the number of elements to be entered to the array. And the input for that output statement is hen. I'm giving cin, that is to hen, and the output statement for the next two choices like enter one for enter one for the linear search and enter two for the binary search, and we'll enter your choice, and then the input statement will be your option, and then the branching statement starts here. That is the switch. I'm using a switch branching statement with a variable of hop, and I have the case one, that is a variable flag is equal to 0, a condition, and then we are giving our output statement as enter. That means the elements to be elements to the array. The n will be the number of input that we gave in the starting. So enter the maximum number of elements in an array. Then I'm using a for loop there for the condition. This loop is just a loop, like normally we'll have two loops, but here I'm using only one loop, that is I is equal to 0, then I is less than n, I plus this, in this the input will be a of I, and I'm giving that enter the element to be searched. After once entering all the elements in an array, we have to search the element. So the variable that I've used here as input is key, and then I've again given a looping statement for. I'm given a condition inside the for loop as if a of I is equal to key, then the flag is equal to 1, that you will have the output as element has been found. If it is equal to, if the flag is equal to 0, and the element is not found. The first condition is the array, the item of the array should be equal to the key, that is the variable that that is the input variable, then the element will be found. If the flag is equal to 0, and then the element will not be found. And then I'm using the second case. The second case is for the binary statement, binary search, and the first case is for the linear search. And here I'm using a condition of int co is equals to -1. I'm actually initializing a value as -1, and then flag also I'm actually initializing as 0, and in output statement is enter the elements to the array in a sorted manner. In linear, you can search all the elements in any order, but in a binary everything should be in a sorted manner. I'm using the same for loop with the same condition, and you'll have this and you'll have only the condition changed here, that is int mid beg is equals to 0, int last is equals to hen. Here in the binary means the search will take place like a sorted array will be divided into 2, the midterm value will be taken, and if the element is supposed to be searched is less than the midterm, then you will have that the int mid beg is equals to 0, and if it is larger than the middle term, that is last is equals to n. Having the first condition that beg is less than or equal to 0, so we have to add it, that is plus co will be increased. And then we're having a condition like if the formula for the middle, so middle is equals to last plus beg divided by 2, and we have a condition there if a of mid, the array of the middle value is equal to k, then the element is found in the so and so position, and then the condition flag is equal to 1 will be true. Or else if a of mid value is less than the key, that is less than the element that we give in the array, then you'll have beg is equals to the middle, and middle should be last plus beg divided by 2. Or else this condition is for the whole loop, that is a of mid should be greater than k. If it is greater than k, then we'll be searching from the middle to the right. If it is less than key, we'll be searching in the left hand side. So, and then I'm ending the thing with a if statement, that is if flag is equal to 0, and then the element will not be found. So now let's see the output. So enter the number of elements to be entered in an array. Example, I'm giving 5. So first I want my linear search to be done. Linear search can be in any order. So I'm giving a random number. So the elements to be searched, I want 8 to be searched. So the element is found at A2. That is 0, 1 and 2. And now let's see the output for the binary search. I'm giving the same number as 5. 2 for the binary. Enter 5 elements. So it should be in a sorted way. So I'm giving elements in the sorted manner. Enter the element to be searched. I want the element 9 to be, like, let me run the program once again. I'm giving 5. So I'm giving again the binary searches to enter the elements, 5 elements. I should give only 5. If I give more than 5, the user will not accept it. I want to find the value 9. So the element has been found in 1. Like when you see, it is easy to find out, but the binary search will divide it into 2. That is, the middle value will be 10. It will divide this as 1 and this as 1. Then it will take the element 9, whether it is less than, that is where we saw the condition here. A of mid is less than key. So A of mid will be 10. That should be less than the key. That is the middle value of 10. So 9 is less than key. Then it will start searching from the left side. If that 9 is like greater than 10, and it will be starting from the right side. So like this is the end of the program. Thank you.